This video is going to focus on understanding how to draw Lewis dot structures predominantly, and then also shift to understanding how to do Lewis dot structures for ionic compounds. So far we've talked about how you count valence electrons for different elements on the table, 1 through 8, and we've talked about the different bonding. What we're going to do here is make the next step to showing how the bonding is happening, given that the valence electrons are doing the bonding. Okay, so step 1, we need a way to picture what's going on. And how we do that is through something called Lewis dot structures. So on the screen here, you have the Lewis dot structures for the 8 main group elements that we're going to be kind of dealing with, those 8 columns, and what the Lewis dots look like. Okay, so we know from our periodic table the number of valence electrons for each of these columns. Each dot is representing an electron. So I'm writing at the top how many valence electrons each one has, and then you can look at the structures to see how we're representing those. So there's just a couple rules when drawing Lewis dot structures. One thing you're going to notice is that for columns 1 through 4, and for valence electrons of 1 through 4, we don't ever pair our electrons up. Okay, so something that happens in a bond is when you have one stick, that's actually representing 2 electrons, or what we call a bonded pair. Okay, so each bond is full of 2 electrons. When we're drawing Lewis dots, we're showing how the atom doesn't have any paired up electrons or bonds yet by spreading out the electrons as much as possible. Essentially, what you can think about, let's say for carbon, is that carbon is an actual atom here. And electrons don't like each other, right? They're totally negative. So the 4 valence electrons for carbon are going to want to spread out as much as possible. So if you imagine that atom is a box, the way we get those 4 spread apart as much as possible is by putting 1 per quadrant or 1 per side. If I end up with 5 electrons, like I do for nitrogen, now one of those 5th is going to have to pair. Know that it doesn't matter which side of the atom I make that pair. Okay, as we draw Lewis dot structures, you might be able to determine which side makes the most sense in relation to how it's bonding. Because essentially how it works for nitrogen right now with what I just drew is these 3 spots where it's not bonded, those are what I would call potential bonding sites for nitrogen. So if nitrogen was going to form a bond with hydrogen, and hydrogen has 1 electron, they would form that bond here, where in the end they get that bonded pair, versus choosing to put the paired electrons on this side and then trying to bond hydrogen up, because 3 does not a bond make. Okay, 2 does. So that's just a little like precursor to where we're headed. But the way you draw a Lewis dot structure is any element on the table you want to draw it for, you write down the element big and proud, count up the number of valence electrons. Sulfur has 6. And then normally how I do it is I put 1 per side, 1, 2, 3, 4, and then pair up 5, 6. And again, it doesn't matter where you pair them, next to each other, across from each other, whatever you want. A couple more word things then. If you look down here at the bottom, I have this lone pair. A lone pair is when you do end up having a pair, okay? Because those are a pair that's not going to end up in the bond, so we call them a lone pair. And then again, those unbonded or unshared electrons will be where you have a single. Okay, so that's just how to draw a Lewis dot, because when it comes to trying to figure out bonding, what we need to know is what valence electrons elements have, what they bring to the bonding party, and then figure out what the electrons do to make the bond happen. So this video is only going to focus on how to make ionic Lewis dots. Okay, they're much easier than covalence, because for ionic, 1 loses and 1 gains, and there's only one way that you can do that so that everyone gets 8. Covalent, on the other hand, when we're sharing, there's lots of ways we can share in order to get to 8 electrons. Okay. When I draw a Lewis dot, I'm going to show charges in the upper right, and I'm also going to bracket. I'll show you what that means here on the next slide. Okay. So if I'm making an ionic bond, and I have 4 examples here, and you can tell each of them is an ionic bond because each of them has a metal with a nonmetal. So step 1 when I'm trying to make an ionic bond is I'm going to draw the Lewis dot structure for each of the 2 elements. So potassium is a 1, so I'm going to give him his 1. And chlorine is a 7, so again, I'm going to go 1, 2, 3, 4, and then 5, 6, 7. I drew those where I did because I wanted to leave the one open that's near potassium. That's just something I kind of do from experience. Now I'm going to figure out how it's going to ionic bond. Potassium is going to lose and chlorine's going to gain. How do I know that? Well, I know from memorizing the periodic table, potassium wants to make a +1 and chlorine wants to make a -1. So plus means less. So if I take the electron away from a potassium and I give it to chlorine, now everyone's happy. Okay? So I'm going to put the charge that's been created in the upper right for each element. And then for the element that ended up with electrons, I'm going to put them in a box. That just kind of contains the electrons and shows that you did that intentionally. Okay. Let me show you another example just to kind of show where this heads. Okay, so sodium has 1 electron and sulfur is 6. 1, 2, 3, 4, 5, 6. So sodium again is going to get rid of its 1 and give it to sulfur. But right now, that's not enough. Sulfur is not happy because it needs 1 more electron right here in order to make an 8. So we're going to grab another sodium with another valence electron. He's going to transfer that guy to the sulfur, thus bringing sulfur update and sodium down to its valence of 8. That means both these sodiums are a +1. The sulfur is now a -2, and I'm going to bracket that guy in again. It just means in the end, the formula for for potassium and chlorine is KCl. But the formula for sodium and sulfur is Na2S. Okay. So another example with calcium and chlorine. Calcium is has 2 valence electrons. So I'm going to draw both of them out there. Chlorine has 7. So we're going to draw those guys out there. 1, 2, 3, 4, 5, 6, 7, and then do what I've been doing. So calcium is going to give 1 to chlorine, right? Now chlorine is super happy with his -1 because he's got 8. But calcium's not happy right now. He's got this extra electron hanging out that he doesn't want. So we're going to need another chlorine with his 7 electrons in order to take 1 of calcium's on, again becoming a -1, but now calcium's going to become a +2. Okay. So the formula for this again, it's just not a 1-to-1 ratio, it's a 1-to-2 ratio. Last example I'm going to show you for the ionic ones are magnesium, which has 2, with oxygen, which has 6. So we can have a scenario where we trade more than 1 electron. So right now we have this perfect scenario where magnesium has 2 electrons he would like to lose, and oxygen would actually like to take on 2, and then they're both happy. So magnesium goes up to the +2, and oxygen goes down to a -2, and they are perfectly satisfied with each other. So Lewis dot is showing us how we actually end up getting the bond in order to satisfy the octets for all the elements. Go ahead and do the few problems I assigned you, and have a nice night.